Marc.
Zoe, all right, thank you. All right, my name is Marc de Gagné. I'm originally from French Canada, from Quebec, and I have an answer for anybody who would want to wonder why I moved to Barcelona, and the weather is probably the #1 excuse. NewTek is actually a startup company, but it's a group of collaborators that have 20 to 30 plus years experience in applied science. And the company itself does not make finished products. We work on developing applicable technologies, and then we transfer to companies who will integrate this to existing or new products and then deliver to the field. We are connected directly to the field because most of the work we do is from demands that are done from real life and translated into problems that are sent to us. And then we investigate and see what can be done about it. So we do participate with what happens out in the field, but always via either product companies or field engineering companies that will handle actual applications. So Terahertz for worker safety. Workers' safety is a major function of the work that we do. It's one of the places where we apply a lot of energy. And I'm going to introduce you to the world of basically of construction. So right now, the work that we didn't even start that work, the project I'm presenting you, by the way, is embryonic. It's just the very beginning. But the goal is to develop a technology based on terahertz, and you will understand why, that will eventually serve for products for the works industry, public works industry, road construction, mining, and port operations. So this is the main title of my presentation, and I'm starting it with a little circle and with a yellow arrow that you can see there. And I want you to see just the kind of dirt and mud that sticks on the equipment, never mind the shovel in the front. And just keep that in mind as I move forward in the presentation. In general public works, and this spans very widely, it includes quarry operations, mining, road construction, bridges, everything. The environment is not really controlled. The environment is very randomized, and workers and machinery have to work together. And although there are a lot of safety protocol in place and all kinds of personal safety equipment, such as a very bright reflective vest, and also some technology features, including rear-view cameras and so on, there's still a great number of accidents because, well, it's you can imagine in these kind of operations that it takes only one moment of inattention for something to happen. Those environments are far more complex and involve a lot of human factor than you would have, say, inside of coordinated places like a manufacturing plant, for example. So in an auto plant, for example, you can control where the workers are walking, where they're not. You could put machinery in cages. You can delimit areas. You don't have this random environment like you can see in construction. And I'm giving you these pictures just to give you a sense of, I want to get rid of this here. All right, just to give you a sense of what those places can look like. So you can imagine all these vehicles moving pretty much randomly, and the workers, when they're walking around, they're not necessarily seeing everything, watching everything. The level of danger is quite high despite the safety training, despite the safety protocols. And these problems come from simple dump trucks to regular cars, all the way to very, very big machinery. And you see an example on the lower right, different zones where workers can actually be at a moment or the machine will start moving because there was some confusion in the work protocol in place. Now, it's super important in those cases, no matter what technology is put in place, that false alarms and annoying alerts are avoided at all costs. Otherwise, it's over. It's never going to be used. So systems that will just be proximity sensors will not distinguish between the person who is in line of sight of the moving vehicle, right in its path, or outside its path. So somebody standing at the red X section, for example, is not in immediate direct path of the vehicle. Workers have to work with machinery and trucks. If a proximity alert is sound, it's just going to annoy everybody who's getting the alarm. So this is a very important feature in application. Work sites are very, very dirty, and they fail due to dirt, mud, water vapor, and a whole bunch of other factors, rain, snow, the general weather. It's just a dirty place to work. And you see on the bottom right what happens to cameras, for example, in such environment. And I can promise you in many sites, this happens within 15 minutes. Cameras get very, very dirty very quickly. And you don't know anymore on the camera if it's mud on the camera, or just dust, or just confusion, or just humidity, or the actual shape of a worker. Never mind the dead angles issue, never mind trying to have 180-degree view or all this stuff. Right now, you cannot even see anything. And this is an unfortunate fact for all systems using any form of optics. So RF signals, and basically all the way up to gigahertz, will penetrate dirt, but it lacks precision. This is where we have a specialty in NewTek. We develop specific technologies that allows us to manipulate the geometry, shape, and size of EM zones. And but without that, it lacks precision and then creates too many false alerts. And it does require some form of electronic personal protection equipment, either a bracelet or a tag, or whether it's RFID, a beacon, doesn't matter, but there's some kind of something that the RF needs to interact with to detect that there's somebody behind. I'm going to go quickly on this. The reason why ultrasonic and radars and stuff like that are not really used, it's because it's very, very important on those sites to distinguish between humans and the rest. Often equipment and vehicles have to maneuver in very tight areas, and they will need to get to centimeters, even touch a wall, stockpile, some equipment. They don't have a choice. The place is very, very tight. In underground tunnels, it's even worse. And thus, the behavior of the operator and the driver differs depending if there's only objects behind them or a wall behind them versus having a human behind them. So again, it's all about false alerts or annoying alerts and not hindering operation. And this distinction is critically important. So there's, how should I say, a set of goals that are mandatory to make this work, and you see it a list right now. I'm not going to go into details. Several technologies have been tested and tried and developed up to now, and the level of success is at best mediocre. Problem with radar is complicated. It's a question of how to distinguish between humans and the rest of the objects. You need a lot of processing power, a lot of filtering. Water drop will confuse them. You cannot assume that it's a human only if it moves, because a human may be standing still. You can analyze the bouncing signal to see if part of energy was absorbed or not, but it takes a lot of processing power to do that. So far, the results were not good. So right now at NewTek, we're investigating two different approaches to solve this problem. One is, in quotes, penetrating photons, and it would be based on imaging, hence recognizing shape of humans in those environments, but without suffering the problem that I showed earlier with the mud and dust and so on. And the other one is to take advantage of the electrical property of living things, of the size of a human, basically, and the interaction of those electrical properties of a human inside a specific electric field. So I'm not going to address this one today. The subject is terahertz, so I'll move on to the second option. So the first option, E-field interfering sensing, we're already working on that. We already have work in progress on this one. It looks promising, but yeah, it's still a lot of work to do. The second one is the one that is embryonic. It's the one we're just about to start now. And the idea is to use the lowest possible terahertz frequency that would still provide us with image recognition. So penetrating photons and imaging. Again, I have to bring this over, this famous image from the camera, so that this is what we're dealing with. Normal light will just not go through. So we need to do better than that. We need waves, EM waves, that will actually penetrate the stuff that's thrown at it. So I have this little table I want to show you. Imagine the scenario where we have camera, sensor, call it what you want here, and we have the subjects here, and I put them dark on purpose just to imagine that this is being done at nighttime. A lot of construction is actually done at nighttime, but yeah, just to give you a little bit idea. The little square that you see here, the gray zone on top of the camera, I hope you can see my cursor, on top of the lens, is just representative of dust and dirt and anything else that can interfere, snow, ice, whatever. And so, of course, under normal images, well, the light, part of the light will be absorbed by the substances in front of the lens, and part of it will be reflected, and none of it will be detected by the camera. So we don't get information that we need to know if there's a human behind or not. Infrared cameras will do a little bit better, but not that much better. And we're going to have a similar phenomenon. It will penetrate a little bit more, but most of the energy will be either absorbed or reflected. So again, we don't have sufficient data to do the work. RF and microwave will penetrate just fine. So the antenna will get it. There's no problem there. But it requires some kind of a device on the worker themselves. And this is a problem because of logistics. Those companies employed a lot of subcontractors and a lot of temporary workers. And that is also very randomized on those sites. So to manage PPEs is very complicated. It's already complicated for simple things like vest and head set and the boots. So you can imagine for an electronic device like this, it's not really visible, it's hard to check. They tried various solutions, but control is complicated. And those devices, well, you have almost to treat them as consumable because they can get expensive. Employers have a real difficulty in paying for devices that the workers will be responsible for or hold. And recovering those devices, especially from the temporary workforce and the subcontractor, is also very complicated. So what you will end up having is that some workers will be protected and some workers won't be. And as far as safety is concerned, that's a big no-no. You cannot have approximate safety. People, mentally, they will be under the impression they have some level of protection when it's not necessarily true. So this is the main issue with RF and microwave.
Sorry to interrupt, Marc.
Yep.
You have 1 or maybe a couple of minutes more, if that's fine.
Okay.
All right. Thank you.
So what we're trying here is something in between where the camera can finally see the radiation and not need any device on the worker. And this is where terahertz comes in. So terahertz is a gap between two worlds. It can be seen as a glass half full or half empty. It does badly with electronics. It does badly with optics, but it does a bit with electronic and it does a bit with optics. And that's the glass half full that I'm working with. And the purpose is really to, how should I say, to get the advantage of a lower frequency being able to penetrate the mud and everything else, and but still have enough resolution and contrast to make up images. So that's the purpose of the project. Usually with terahertz, when you see scanners, when you see something similar like X-rays, there's a light source being used. You have something between the light source and the camera picks up the result. Sometimes the configuration is different with bouncing signals. The problem with applying a second source is installation, because in those pieces of equipment, especially on the truck on the upper left, you can imagine that placing 2-3 devices, it's going to get very complicated. It can be costly to align it. You have to spread wide enough to cover the zone. So that's not really the approach. So what we're doing is approaching the research on T-wave sensing, and to actually sense natural terahertz radiations, which of course will not come from space. And the principle is based on black body radiation, the same as IR, actually, as infrared, but we're aiming for the low end, the low energy portion of it. We're going to zoom on that part where the lens is right now, and we're banking on having just enough energy to still have sufficient resolution and contrast to do the detection. So black body radiation is actually what infrared is grabbing, actually. And it's just that, well, we're trying to make a super sensitive sensor to be able to read that energy, even if it's very, very, very low at lower frequencies, which are terahertz. This is just to show the difference between a light emitting terahertz camera versus what we're trying to do is that to sense natural energy that is emitted by human bodies and the environment, and hopefully have enough outline of the human body to be recognizable by image processing. So infrared cameras are here. We're looking to exploit this section here in the red section. And in this case, even if we have mud or dust, actually the signal should be penetrating enough that we will get a positive signal and be able to identify humans behind it. So even if how should I say, the image is not perfect, I cannot recognize the face of a person, and so on, at least we can recognize the shape of a human, and thus allowing us to do the proper alerting in the case of the construction industry. This is the aim. Those were parameters, and well, that's it. I'm done.
Thanks very much, Marc, for the talk and for trying to push towards being within the time limit.
Yeah.
I forgot to tell everyone, all the attendees, that you can leave your questions for the speakers here in the chat. So to have access to this chat screen, you have it in the bottom part of the WebEx window. You have like a sort of bubble. And if you press it, you'll see that the chat appears on the right. So you can leave your questions here for Marc now if you want. In the meanwhile, so I would like to ask, as far as I understand, terahertz cameras, terahertz devices are more expensive right now than cameras, right? That are almost like cost of the shelf. So yeah. Do you see the prices of these devices going down in the near future for them to be really exploited widely?
Well, obviously, I would hope so. The difficulty with terahertz is that even if terahertz are known and studied for the past century, interest to terahertz is very recent. It's only barely the past 20 years, and I would say mostly the past 10 years. So, and the first application of it was security, like scanning people without using X-rays. And I guess that motivated its development, and there's no budget limit for airport security. I mean, they don't mind paying $200K for scanning inside an airport. Of course, we cannot put this kind of expensive equipment on a dump truck. It doesn't make any sense. It won't fit the market at all. My hope is that there's sufficient new development in the terahertz to motivate the industry. It's mass production. It's all a matter of mass production. So the more there's a diverse utilization of terahertz, the more components will be available at lower costs, and I'm crossing fingers on that. Okay. And so, yeah, that's pretty much, we're early in history, and that's why it's expensive. It's like what PCs were so many years ago.
That's true. That's a good point. So one very quick question, and we have to move on. Yep. From Victor Blanco. He says that he cannot see the advantages of terahertz compared to thermal cameras.
Thermal cameras are still blocked too much. It's a matter of frequency. The lower the frequency, the better the penetration. Basically, that's what it is. IR will work to a limit, but unfortunately, not good enough. It still gets too much interference, and so many times we get confused data, and safety is very particular about this. We have to be sure about the alert that we're producing. There's no other way. If the safety is approximate, it won't be permitted to hit the market. It's as simple as that. So IR is a lot better than normal light, of course, but it's still not quite as penetrating as we need it to be.
Nice.